participated in Atcoder Beginner Contest 190, and now we're going to be going over all the solutions. Or more precisely, we'll go over all the solutions in a minute or two, just to let a couple more people join the stream. But yeah, how was the contest for everyone? Were there any particular problems you liked or curious about? I also solved F using a slightly more technical solution than I would have expected. So I'm definitely curious if there's a better way, but I'll explain the way that I did it, and then maybe we'll see if we can come up with a better way. Or a simpler way. I guess my way was pretty simple, but it requires some advanced data structure. Cool. And I haven't done a stream in a little bit, so I just want to check my audio and video are okay. Cool. A lot of people saying got wrong answer on problem B. On 3 test cases, interesting. Let's see how many test cases I got it on. I got wrong answer on 9 test cases, so definitely beat out that viewer. Cool. Alright, so I guess I'll get started with A, or maybe I'll start in a minute or two. But yeah, overall I thought this was a good contest. Definitely kind of unusual especially for Atcoder, but maybe because it's a beginner contest, they did this, but it was unusually technical. Like, I thought there was a lot more implementation and data structures than in a typical Atcoder contest. But I guess that's good. Like, it's important to familiarize yourself with all the standard algorithms and stuff like that. Okay, cool. Oh, and before we get started, I guess I'll also point out that I upload things to YouTube. And actually now I've started uploading screencasts to YouTube and not just my Twitch archives. So definitely check that out. And I also have a Discord where viewers can kind of connect and chat about stuff. And that's also where I update people about my latest streaming plans and broadcasting plans. So definitely feel free to join there, subscribe on YouTube, and follow here on Twitch. And subscribe on Twitch if you can, of course. But yeah, there's never any need to. Cool. And someone reminded me to hydrate. Thank you. And thanks everyone for the follows. That's definitely awesome to see. Okay. Cool. So it looks like this is a good time to get started. It's been a little bit since the contest ended. So we'll start with A. Cool. So for A, basically you have A was actually much harder than a typical beginner contest A, I felt. Normally it's completely straightforward implementation, and this one I think was slightly trickier. So basically these people have different amounts of candy and they eat candies, taking turns, and whoever runs out of candy when it's their turn, or sorry, the first person who can't eat a piece of candy while it's their turn loses. So who will win? So just to try like a really simple example, let's say they both have 1 candy, then the first person will eat a candy, then the second person will eat a candy, and now the first person loses. Yeah, you could also implement this, I guess, by actually implementing this by doing like a minus minus, b minus minus, etc. But anyway, this is what happens. The first person loses if they have the same number or if the first person has less. And then if c equals 1, then the second player actually goes first. And you can just simulate that by subtracting 1 from the amount of candy that the second player has. So I'll quickly show my code. Yeah, so I mean, as I described, right, you read A and B, you subtract 1 from B if C is 1, and then you write this if statement. And of course with these problems, you always have to be careful to not mistype these strings and to make sure you get less than or equal to instead of greater than or whatever. Cool. So let's move on to B. Someone asked, what theme is that? I'm using Solarized Dark. Yeah, I'm using Windows and I'm using Ubuntu Linux on Windows using WSL. That way I can use Windows for like gaming and like streaming and stuff, but then I can use Linux for compiling and writing code, which is definitely more convenient. Okay, cool. So let's go over B. B was basically like a reading test. So if the damage, so the monster will avoid spells that are longer than S seconds. So we require that the duration is less than S, and we require that the damage is greater than D in order to do damage. So basically what we want to do here is we want to check if any one of your spells can damage them. So you just read the input and you loop through this, and you check if any of them are true, and then you say either yes or no. So let's look at the code. And this is definitely one where you have to read carefully. So kind of as I described here, right, we read each x and y and we just check this. Initially, I actually did this because I misread, I just misread the problem or was trying to rush through it too quickly. And I ended up getting a wrong answer submission. And then I noticed it after I did C, and then I went back and fixed it. But that's definitely kind of annoying. Cool. So, alright, let's go over C. It's actually already getting to a bit of a tricky one. Alright, let me catch up with chat. So okay, someone said, but it got wrong answer. Yeah. So I got wrong answer on my first submission. But then I resubmitted, reading it correctly, for B. And then someone said D was misprinted. Oh, was this the yeah, I saw that. This is a nice catch that they didn't include only integers. Definitely kind of a funny mistake. I actually didn't catch it. I just kind of did the problem as intended. So Sherzad is saying in the chat that I got wrong answer, but I think not. So like this is my submitted code, right, where I had x less than S and y greater than D, and then this one actually did get accepted. Okay, cool. So let's move on to C. So at first, C definitely seems kind of tricky, but whenever you read these problems, you always want to look for the constraints. So in this case, the first constraint is C is less than or equal to 16. Or sorry, K is less than or equal to 16. So this is actually very small, which means that you can probably do some relatively inefficient algorithm and it'll actually be fine because k is so small. So now let's actually read the problem. You have n dishes, so let's draw some dishes. And a condition is saying that a pair of dishes both have at least one ball. So the first observation here is we don't actually need to count how many balls are in each dish, because the only operations you can do are add one ball or check if something has at least one ball. So you can express all the dishes as like booleans of whether they have any ball at all or not. So like whether they're empty or whether they have something on them. And then, so let's say we had a configuration of what choices each person made. So each person can either choose CI or DI. So there's 2 to the k different choices. And let's say we knew what all their choices were, then we could compute the score. The way that we would do that is simply just, assign all the balls wherever they go, and then just go through each condition and see how long that would, or see how many conditions are satisfied. So this would be the number of conditions plus n times 2 to the k. Something like this. So for each of the configurations, you would just assign, technically there's a plus k in here too, but it doesn't really matter. But yeah, so the idea is you want to go through each configuration and then check it. So this is small enough that this will run in time. And I think the cleanest way to do this is by using bit masks. You can also do it recursively, but I find the bitmask solution a little bit easier to just code. It's like a simple for loop through all subsets. So our conditions are just pairs or 2 length arrays. And then our people are the same thing. And we're 0 indexing everything. And then here, this is 2 to the k. So we're going through all the binary numbers less than 2 to the k. And each of those corresponds to a set of decisions. So if the ith bit in the mask is 1, then we're saying that they're going to put a ball into dish DI. And if the ith bit is 0, then they're going to put a ball into dish CI. So here we're assigning the balls to the dishes, and then here we're computing our score, and then we simply take the max. And this is one of the problems that has a lot of different variables, n, k, and m. So be really careful not to mix those up. I definitely I initialized people to m earlier and then was getting runtime errors, things like that. So be careful of that. But otherwise, this is a fairly straightforward, just try everything implementation problem. Okay, so getting a few more questions from chat. How to solve it for larger n and k? I'm not actually sure. And someone said vector of bool is slow. Slow compared to what? I thought vectors of bools were fast enough compared to the other stuff that we're doing, at least. Someone said, can you code recursion? Well, so recursively going through all subsets is a very standard problem. So I'm not going to code it on stream. Well, we have common doubts. Okay. Something. Did you do binary search? Yeah, so I'm going to get to D in a second. And then... someone said, what's better, array int 2 or pair int int? So this is totally subjective, right? The difference is just whether you do 0 and 1, or you do first and second. And then the other thing that's nice about an array is you can loop through the elements, so it reduces the chance of making typos. There's less code duplication this way. In general, I think it's probably good to use arrays when the two items are the same thing. And by that, I don't just mean that they're the same type, like I don't mean that they're both ints or they're both longs or whatever, but I mean that they're like conceptually the same thing. So here, like these are conceptually the same thing because they're both indices of dishes, and same with here. But you could imagine a problem where you would have like a pair where the first thing is like the cost and the second thing is like the value, or something like that. And for those, I would recommend like using a pair there is nice because then you can kind of keep track of first or second. Or better yet, you can just define a custom struct with dot cost and dot value if you really want to be careful not to make mistakes. Have I ever participated in IOI? No, I did not. I'm pretty sure I would not be able to qualify even now. And I was definitely not as good at competitive programming in high school as I am now. I'm from the US, so it's very, very competitive, I think. I did go to the International Physics Olympiad, though, from the US. Back in high school, a long time ago. Cool. So let's go over D. Oh, and real quick, someone said, is it possible to do a DFS on C? Yeah, I mean, DFS and the recursive solution that someone else mentioned are the same thing. Cool. All right, wow. I'll use my tablet instead of my mouse. Okay, so for D, we want to figure out how many arithmetic progressions consisting only of integers with a common difference of 1 have a sum of n. And what's kind of cool about that is they have some cool examples here where like you can actually have like positives and negatives that cancel each other out. But basically the way that I thought about it is the sum of an arithmetic progression is the average value times the count divided by 2. So what this means is we want to find two integers, and the average value may not be an integer. Oh wait, hold on. Okay, sorry. There's no divided by 2 here. Right, it's just the average value times the count. I think I was a little sloppy with my notation. So yeah, the sum is the average value times the count. And for example, if you have 3, 4, 5, the average value is 4 and the count is 3, and that gives you 12. The count being the number of elements. And the average value being the middle element, or if you have two middle elements, like if you have like 5, 6, then that would be 5.5 times 2. Yeah, and someone else said n over 2 times first term plus last term, which is the same idea. You end up, n over 2 is the count divided by 2, and first term plus last term is twice the average. So the average might not be an integer, which is definitely kind of annoying here. But if you do 2 times the sum, then that's equal to 2 times the average, or the first term plus the last term, as other people said, times the count. And now 2 times the average and the count are both integers. The last kind of observation is that if the count is odd, then the average is an integer. And if the count is even, then the average is a half integer. So this means that 2 times the average is even only when count is odd, and it's odd only when count is even. So these two terms will have opposite parity. So from here, the way that I did this is I just counted all the different factors of n, or actually of 2n. right? Because 2 times the sum. And I checked for pairs of factors that had opposite parity. And then, just to keep things simple, I added everything to a set to deduplicate stuff so I didn't have to worry about edge cases. So let's take a look at the code. So yeah, so here average, so this is actually I guess wrong. This should be like 2 times average times count equals 2 times n. So I multiply n by 2 right off the bat, and then here we can factor n in square root of n time. And obviously if you don't find a factor, you skip, and then if the parity is the same, then you skip. Otherwise, the count could either be I or n over I. You could either have like 10 terms that average to 5, or you could have 5 terms that average to 10. Or average to half of those things, but you know what I mean. And then the cool thing here is just you don't have to worry about accidentally adding something twice. You just print the size of your set. It adds an extra log factor to the runtime, but that's not really a concern. Cool. So that's D. Someone else said I used binary search by fixing one value. So, but could not get AC. That's actually interesting. So how did you do binary search? Like what value did you fix? D can also be solved by 2 times count of odd divisors. Is that right? Count of odd divisors. Oh, because 2 times n is always, okay, that makes sense, yeah, so 2n is always even. So the 2 divisors, if one of them is odd, the other one will always be even. So that's basically equivalent to what I did, but another cool way to think about it. Cool. Yeah, I guess I see that some people mentioned like a binary search, but I guess also mentioned that it didn't work. So I'm not really sure what the idea there is. Okay, cool. So, but yeah, I think this is definitely the simplest solution. It's like, you know, just looping over the factors and then doing a little basic conditions and bookkeeping. Alright, so now let's solve E. I'm kind of interested if there's a nicer way to do E, but the way that I did it was quite straightforward, just a little bit troublesome to code perhaps, or a little bit long maybe to code. It had a bunch of little steps. But basically we have this pretty complicated looking problem where we have so let's just go through the first example. So in the first example, you have gems 1, 2, and 3 that are all connected to gem type 4, right? You can kind of imagine this input as a graph. And then we want to have all of 1, 2, and 3 in our thing. So, someone said notepad link. Yeah, I can link the Jamboard if that's helpful. That way if I go back or something, people can cool. Yeah, so now if people want to look at the whiteboard live, they can do that. Cool. And then someone else asked, are you going to post your code to GitHub? I don't post my submissions for contests to GitHub because you can always just go to the website and look at my submissions, either on Code Voices or Atcoder or whatever website. So I figure there's no point in that. It's just like additional bookkeeping. My Atcoder profile is just on Indoza. If someone else could link it in the chat, that'd be cool. But you can also just go to it. Okay, so let's see. Okay, so where were we? We're going through this example. So the idea here is we could start by like adding a 1, then we can add a 4 and a 2. We can't add 2 directly because there's no connection. And then you could add a 4 and a 3, and then that gives you the answer of 5. So the thing to note here is that stuff like 4 isn't actually like helpful, in the sense that we don't really care whether it's in our final thing or not. It's just kind of a means to an end to allow us to add other things. So we can also think about this by finding the cost between every pair of special gems. So this would be like something like this, where this cost is 2, and actually all these costs are 2. So what this means is you can get from 1 to 2 by adding 2 gems, and it doesn't really matter what those 2 gems are. It's just important that the cost is equal to 2. So first we want to find this, right? Because the thing is, there are actually, if you look at the constraints again, there are 100,000 different total gems, but there are only 17 special gems. So reducing our graph from 100,000 nodes to 17 nodes is definitely helpful. So we can solve this by using breadth first search. So you start from every, the simple way to do it at least, is you start from every special node, and then you do a breadth first search, and then you find the distance to all the other special nodes. So this ends up taking k times something like this runtime. Oh, someone said I'm doing this well. Thank you. Cool. So first we want to do this via BFS, and then that takes O of k times the size of the graph. And now we've reduced our graph to a graph with k vertices and k squared edges, where we just have the distance between any pair. And some of those distances could be infinity, so be careful of that. Like it might be the case that there are gems that you can't ever connect to each other. So now from this point, we want to do a bitmask DP. So our DP state is going to be the minimum cost to get some set S with last gem J. By the way, is my video still good? I guess some people are talking about their screen being frozen, so. Okay, cool. Yeah, if you're having audio or video issues, I recommend just refreshing. It's probably an issue on your end. Thanks everybody for confirming. I guess I'll go to the next page. So, looking at this approach, once we have like some prefix of the ornament, the only thing we care about is what gems appear in it, and then what the last gem is when we're thinking about what we're going to add to the end. So that kind of is what leads us to our DP state of, this is a pretty standard bitmask DP problem, where your DP state is which gems you have so far, and then what the very last gem is. Oh, by the way, please just stick to English in the chat. Let me just clarify. I only speak English. So yeah, I just want to make sure everything in the chat is something that I can read at least. Thank you. By the way, what did that mean in English? Let me know. Okay, so our DP state, right? So we have 2 to the k for the possible subsets. And then we have k for the what the last element could be. And then to do a transition in our DP, I did it in time k. So our total runtime is k squared times 2 to the k. And if you kind of plug in 17, this is fast enough. Yeah, this is definitely a bit of a technical problem, so I think looking at the code will definitely be helpful. LeBron says, did that remind you of Traveling Salesman DP? I guess this is also how you do Traveling Salesman, right? This is exactly the Traveling Salesman problem. It's like you have a bunch of gems that you want to visit. I guess I didn't think about that. I don't often think about Traveling Salesman, but now that you pointed out, it is the same as that standard problem. Cool. So let's just go over the code. Definitely a bit long. Oh, and Traveling Salesman, are you supposed to go home at the end as well? I didn't realize that. And then Denko Ra says, can DP be reduced to just the bit masks and not the second dimension? And that, I'm actually not sure. If anyone else knows, that would be awesome to hear. But cool. So first we read in the whole graph, and then we read in the list of special vertices. Then here we just coded a standard breadth first search, and then at the end what we do is we get the distance to each of the special vertices out from that. So we start at each special vertex one at a time, and then here we end up having a 2-dimensional adjacency matrix, basically. And here I made infinity 1 billion, which is large enough that it'll be larger than any actual value we're ever going to get, but it'll be... Actually, is that right? Yeah, that's right. Cool. But it's small enough that if you do infinity plus infinity, you won't overflow. Cool. So then here's our DP state. And I always find this helpful when writing out a DP, especially a 2-dimensional one. Just a simple comment saying what the value is and what the 2 indices mean is definitely helpful just to help keep track of everything. So yeah, so as I described, DP ij is the minimum cost to get all the stuff in I, which is a bit mask describing a subset, and the last element being j. Oh, and if you want to know about my solutions to the previous problems, you can always just go back in the Twitch video. Cool. So to initialize our DP, the cost is 1 for any individual element. So take care that it's 1 and not 0, because you do have to add that first gem. Actually, I think... No, yeah, I think this is the cleanest way to do it. So yeah, you start with 1 with each element. Wait a second. This is definitely wrong, isn't it? Wait, how did this pass? So here I'm saying that you have no elements, and the cost is 1. Shouldn't that mean that you have to go back to the first element later? It's super weird. Okay, I'll think about this in a minute, but I'll outline the broad strokes of the solution. So what we're doing is we're going through each of our DP states and we're considering adding one more special gem on the end. So what we're doing is our new set is going to be setting that bit of our bit mask to 1 and saying that this is the last element, and then our cost will be the previous cost plus the cost of the step. And then at the end, we want to find the minimum cost to get all the elements, regardless of what the starting... let me time out. Please don't spam the chat. So, yeah, so we want to find the minimum cost to get everything, no matter what the last element is. But what's definitely a little weird here is this seems wrong. Let's see if anyone in the chat has any insight. Distance from something to itself is 0. Ah. Okay, cool. So it turns out that this works because at the very first iteration, what we'll do is we'll go through all these empty sets, and then we'll say the distance from something to itself is 0. Thanks for pointing that out. So we'll set all the single element subsets to be 1 as well, because it'll be this starting thing plus 1. Okay, cool. So I actually coded this, like, I think, maybe I thought of that during the contest, but I think I didn't. I think I just made a mistake and it worked out. So yeah, this is a slightly confusing way to write it, but it's still correct as pointed out by the chat. But yeah, this is basically a problem where it's a combination of a bunch of standard techniques, like breadth first search, completely standard, bitmask DP, completely standard, and then you know, you have to figure out how to combine them, right? Cool. So let's look at F. So F was definitely, I think, a pretty difficult problem here. Oh, I guess I'll point out one more thing about E. If all the C's don't belong to the same connected component, return -1. Yeah, you could also do that. I figured instead of adding a special case, I'll just check at the end if it's impossible. And yeah, always be careful of this. If answer is equal to infinity, then you want to set it back to -1. Cool. So for F, we want to count inversions, which is a standard problem. But some people are saying F was easier than E. That's interesting. So I guess I'll say up front that I solved F using a persistent segment tree. I guess I probably could have done a little bit more bookkeeping and solved it using only Fenwick, but it seemed kind of like, even with using like such a powerful data structure, I still felt like thinking about the problem was kind of tricky. Whereas E was like completely standard. Though I guess E, it also comes up with a bit of time to get the right idea. But yeah, cool. So let's try to understand what F is even asking. So the inversion number of a permutation is a pretty standard idea. So if you have a sorted permutation, the inversion number is 0. If you have some permutation like this, the inversion number is 1 because there's one inversion. An inversion is a pair of elements that are misordered. Yeah, as people are saying, you can use policy-based data structures, order statistics tree, or you can just use Fenwick tree. Either way works. Someone said merge sort. I assume that means merge sort tree, which I don't even know. I think it's like some very advanced data structure. Okay, cool. So then let's just give one more example of a inversion number. So here, this would be 2 inversions. Okay, what is this carrying a cat thing? Definitely. I'm gonna time out the other person who was spamming. But anyways, all right. So getting back to this problem, so first let's figure out how to compute the inversion number of just a simple array, right? Which would be like the first number that we're supposed to print here, instead of considering all the shifts or all the rotations, I guess. So the way that I would do that is using a Fenwick tree. What you can do is you can sweep left to right. So for each element, the inversions that you add are the number of elements before it that are greater than it. So what you do is you sweep left to right and you add all of your elements into some data structure, like a Fenwick tree or like a order statistics tree or similar, and you just use that to count how much stuff is before it. You can also use a segment tree. Cool. So the idea here now, right, is that this will let us find the total number of inversions in the thing, and we can also, what we're doing along the way is we're finding the number of inversions in every prefix as well. So that's kind of a standard problem. So let's look at the code. I definitely I don't know. I kind of just coded this the first way that I thought could be effective. So here I find the inversion number for every prefix of the array. And the way that I do that is, as I mentioned, you set the current value you add the current value into your data structure, and then you count the number of things that are greater than your current value that you've already added. So, and that's how many things you're adding to the inversion number at each step. And then for the suffixes, I just went through the array from right to left instead, and I counted the number of things that are less than instead of greater than. And then here I just put this in as a quick check, because I defined my suffixes as the last I elements and prefixes the first I elements. So when you take all the elements, they should be equal, and that would be the inversion number of the whole array. Cool. So that gives us the inversion number for all the prefixes and all the suffixes. And then we want to see how the inversion number changes as we move one element from the back to the front. So let's go through an example of that. So first of all, if we have some, I guess I'll go to the next page. And let's say we have some array like A, B, C, D, E. And then we shift it to get something like C, D, E, A, B. Now, the inversions here are the inversions inside of this, the inversions inside of this, and the inversions that cross over them. And someone asked, what do the curly braces do? It just initializes it to a vector of length 1 with that element in it. So what we want to do here is we can find each of these things by just looking at a prefix or a suffix of the original array. And then now we want to figure out how to figure out how many crossing over pairs there are. So the way that I approach this is, let's say you have A, B, C, D, E, and you want to move A to the end. So we're adding inversions for all the elements here we're adding all the elements in this range that are greater than A. And actually that's it for now. But then let's say we have already done that, and then we're gonna we're going to cross out B as well and move it over here. So now this thing actually would be, this would be what we get for A. So effectively what we can do is we can subtract out however many times B is greater than this stuff in here. So this is definitely a little bit complicated sounding, but let's look at the code. So what we want to do is first prefix I+1 and suffix n minus I+1 is just the stuff inside the prefix or the suffix. Let me just catch up with chat. Yeah, there's a fake Neil Wu in the chat. Very cool. Or maybe it's someone else who's also just named Neil Wu. I don't want to make assumptions. So here we're computing wrapped, which is the stuff from this wraparound. So the idea here is when we move an element to the end, we're adding for all the stuff that... Well, first I'll just explain these helper functions without thinking about the implementation of them. So this is counting in a range how much stuff is greater than V, and this is counting in a range how much stuff is less than V. So for all the elements in this suffix that are greater than V, we're adding one more inversion. And then for all the elements in for all the elements that you've already wrapped around or that you've already moved, we're actually removing one of their inversions because the currently moved element is in the suffix that you would have added here, like at a previous iteration of the for loop. So that's basically it. That's how you solve the problem. And then implementation-wise, I implemented these using a persistent segment tree. So what a persistent segment tree does is it's basically a regular segment tree, except it saves a snapshot at every timestamp. So what we do is we put in all the elements from left to right, and we put them in at a time equal to their current index. So then what we can do is we can query any range before a timestamp. So if you do that, then that basically lets you find the answer to this problem, which is a range of indices corresponds to a range of timestamps in the segment tree, and a range of values corresponds to a range of indices in the segment tree. So that's how you'd use persistent segment tree to do this. Because we're only ever looking at prefixes and suffixes around I here, I think you could also just maintain like a Fenwick tree or like a simple data structure to do this. So this might be a little bit overkill, but if you have the code pre-written for a persistent segment tree, you might as well use it. Cool. So that's all the problems from this contest. Does anyone have any other thoughts or questions about the contest? Oh, and also I wanted to know, wow, a ton of people are saying that F was easy. That's awesome. I guess that means they're really familiar with these kinds of things. Yeah, I guess let's look at standings. If we look at rated only, wow, 1,200 people solved F. That's pretty cool. Oh, and also, is anybody doing Code Chef? I've only done one Code Chef contest ever, but I think there's a lunchtime in like an hour, so I might do it. Because I don't know, it might be fun, but I might not. Also, we'll definitely see. Oh, it's in 25 minutes. Wow. Okay, so if I'm doing it, I better hurry to do it. So yeah, it seems like F was solved by a ton of people. That's interesting. I hope I reach 5 stars. I think I'm a 3-star coder on Code Chef. um, wait, sorry, it's in 55 minutes. Wait, okay, so it is in like an hour now. I guess we can see Code Chef. Okay, cool. So it's in like an hour, so I guess I have time. Uh, am I in the U.S.? Yeah, I've been in the U.S. my whole life, other than vacations, of course. Okay, cool. And then LeBron asked, "What was my favorite problem?" And I actually liked F. A lot of people are saying it's pretty easy, but the reason that I liked it is because I haven't really used. I only learned how to use persistent segment tree like maybe a couple months ago at most. And so I was kind of happy that I was able to like successfully apply it. Um, how difficult is lunchtime? That's a great question. I would also like to know how difficult lunchtime is, if anyone knows. Uh, though I'm gonna be in Division 2, so I don't care how hard Division 1 is. Um, yeah, they have Division. I was almost in Division 3 actually. My Code Chef rating is like just over 1600, I think. Um, Lunchtime is pretty easy. I'm having lunch every day. That's actually a pretty good one. Yeah. The Neo Wu who is very high rated on Code Forces um is a mod on my chat, so you'll be able to identify that um that's a real person. Um, cool. So I guess that wraps up this stream. Thanks so much everyone for joining. A couple quick notes. You can check out my YouTube, and on my YouTube, um, I actually uploaded a screencast to this contest so you can see me solve them live. I got a ton of segment faults. um, am I gonna do Code Chef live? I mean, I'll probably do it later. I mean, I'll do it live, but I'm not gonna stream it, of course. um, am I gonna upload this stream on YouTube? Yeah, so I'm gonna upload this stream on YouTube as well. I upload my broadcast typically in 1 to 2 days. My screencast is already up there. I'm probably not going to. Okay, I guess. Okay, people in the chat are going a little bit wild. Please stop spamming about Zero Judge. I don't know what it is, but um, and someone asked how old am I? I'm in my late 20s. Um, so yeah, stuff like high school contests were a long time ago for me. um, yeah, so thanks so much, everyone. Just trying to keep up with chat a little bit, and definitely feel free to join my Discord, and check out my YouTube. And of course, follow here if you'd like to see future Twitch streams. And someone's asking, can I do a mashup on probability and expected value? Yeah, I am kind of vaguely planning to do a mashup on combinatorics and expected value in the future. But it's a lot of work to make a mashup, so we'll kind of see when I get to it. It's kind of been on the back burner. Did I attempt IOI? I did some Musico in high school, but I kind of quit in the second half of high school and focused more on math and physics. And I never made it to the training camp or to IOI. LeBron says, thanks for the clear explanation. Yeah, thank you. Thanks everybody for tuning in. And Frightened Swan says, who's my favorite competitive programmer? I'm not sure. There are a lot of competitive programmers that I know that are super cool. So definitely a big fan of a lot of them. Don't wanna play favorites. Okay, I'm gonna ban. I can do that after the stream. I go wild. Okay, that actually did give me a laugh. Anyway, thanks so much everyone for joining. And definitely check out my other links, and I'll catch everyone next time.